Hello students, in this video I am going to explain you errors encountered in measurement and numerical based on them. Let us start. The deviation of the measured value from the actual value of a quantity is called an error. The errors in measurement can be classified as systematic error and random error. The systematic errors are those errors that are caused due to known source. They tend to be either positive or negative. There are various sources of systematic errors like instrumental error, imperfection in experimental techniques, and personal errors. Instrumental errors are those which arise due to the imperfect design or calibration of the measuring instrument, and imperfect techniques or procedures in the measurement lead to the imperfection experimental procedure. The personal errors are due to wrong setting or improper use of apparatus, that is, due to the carelessness in taking observations. Such errors can be minimized by improving the experimental techniques, selection of better instruments, and being careful while taking observations. Random errors. Random errors are those which occur irregularly. These errors arise due to unpredictable fluctuations in experimental conditions. They are irregular with respect to sign and size. So, using high precision instruments and improved techniques, error can be reduced. Also, by repeating the observation several times and taking its arithmetic mean, we would be very close to the true value. Now, suppose we have taken a number of observations and let the observations be represented as A1, A2, A3 and so on. The arithmetic mean of these values is taken as the best possible value or the true value of the quantity under measurement, and the arithmetic mean is calculated as sum of all measurement divided by the number of measurements. Here it is n. Absolute error in the measurement of a physical quantity is the magnitude of the difference between the true value and the measured value of the quantity. Here the true value is the mean we have just calculated, and A1, A2, A3 are the number of observations. It is denoted by mod of del A, that is delta A, that is representation of absolute error. Mean absolute error is the arithmetic mean of the magnitude of absolute errors in all measurements of the quantity. Mean is calculated by considering all errors in individual measurements as positive, like this, divided by the number of observations. Relative error or fractional error is the ratio of the mean absolute error to the mean value of the quantity measured. That is, relative error is the ratio of the mean absolute error and arithmetic mean. Now, percentage error is simply the relative error when expressed in percentage, like this. When two or more quantities are combined together, then the error in the resultant is also noted. So, let us see that. The error in the sum or difference of two quantities. Here we have considered two quantities as A and B. If we are adding the two quantities or subtracting the two quantities, then in the resultant, the absolute error in the combination of the two quantities will be simply the addition of the absolute individual errors. Error of the product or quotient of two quantities. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative error in the multipliers. For example, again here I have taken the two quantities as A and B and they are multiplied together. So, the relative error in the resultant will be the sum of the individual relative errors. Now, error when a measured quantity is raised to some power. Here the power is k. So, the resultant will be k times the relative error in the individual quantity. Likewise, here I have taken as a raised to the power p, b raised to the power q divided by c raised to the power r. Then, the relative error in the resultant will be simply the summation of the individual relative errors multiplied by their powers. Here A was raised to the power P, So in the resultant, it will be P times relative error of A. For this term, it will be Q times the relative error of B, and for the denominator term, it will be again plus the relative error multiplied by the power. Here the power is R. Now let us practice numerical. Some measurements are taken for a period of oscillations of a simple pendulum. In successive measurement, the reading turns out to be these. Calculate the absolute errors, relative error and percentage error. In order to calculate these errors, we should first be aware of the true value or the mean value. So I have calculated mean value as simply the arithmetic mean by adding all the observations in the numerator divided by the number of observations. Here it is 5. So the answer comes out to be 2.62 seconds. Now the errors in individual measurement values are calculated like this. This is the formula. So the error in the first measurement comes out to be 2.62 minus 2.63. It is minus of 0.01. Then error in the second measurement is calculated at 0.06. Error in the third measurement is calculated as 0.2. Then in the fourth one, minus 0.09. In fifth, minus 0.18. Now, in order to calculate the absolute error, I have to find the mean of all these individual errors by considering them all as positive divided by number of observations. So this will be the equation when I will put all the values. So the absolute error will be equal to 0.11 second. Then I have to calculate the relative error. Relative error is simply the ratio of the absolute error and mean value. So mean value we have calculated earlier, it comes out to be 2.62. So the answer is 0.04. And the percentage error is simply multiplying by 100 into the relative error value, it is 4%. Let us attempt one more numerical. The length and breadth of a rectangle are given. We have to calculate the area of the rectangle within the error limits. So these are the values for the length and breadth. As we are aware, the area of the rectangle is length multiplied by breadth. It comes out to be 19.4 centimeters square. Here the two quantities are multiplied together, and we are aware that when two quantities are multiplied, the relative error in the result is the sum of the relative errors in the multipliers. That is this. So putting down all the values, del L is given in the question as 0.1. Del B is given in the question, that is the absolute errors are given in the question as 0.2, and the length is given as 5.7 and the breadth is given as 3.4. Area we have just calculated as 19.4. Putting down all the values, we are able to calculate the absolute error, that comes out to be 1.5. So putting down in the area, so area, overall area within the error limits comes out to be the value of the area when length and breadth are multiplied, and when we have calculated, or what we have calculated, the error is 1.5. So the overall area becomes 19.4 plus minus 1.5 centimeters square. Third numerical, a physical quantity X is given in this form, and the percentage errors in P, Q, R, S are given as 1%, 2%, 4% and again 2%. We have to calculate the percentage error in X. The relative error in a physical quantity raised to the power K is K times the relative error in the individual quantity. This we have just discussed. So applying the same in the given question, the relative error in X can be calculated if we find out the relative error of the individual quantities multiplied by the raised to the power. P is raised to the power as A, so it will be written like this. That is, A will come out to be here and then multiplied by the relative error. Similarly, for the Q multiplied by B, for denominator terms also in the same manner. Putting down all the values, A is given in the question as 2 because P is raised to the power 2, it is simply A. Q is raised to the power 3 by 2, so here B is 3 by 2. Then R is raised to the power 4, so C is 4 and D is 1 by 2. Putting down all the values, we have calculated the relative error as plus minus 0.22. And in order to calculate it in percentage, I have simply multiplied it by 100, so it comes out to be 22%. Now let us start next numerical. The density of a piece of metal of mass m and volume v is given by the formula, where mass and volume both are given in the numerical. We have to calculate the percentage error in density. We are aware of the formula, density is equal to mass upon volume, and we are also aware that when quantities are divided, the relative error in the result is the sum of the relative errors in the numerator and denominator. So the relative error will be this. Putting down all the values, relative error value of mass m is 0.1 upon 3.5 and relative error of volume v is 0.1 upon 1.5. Calculating the values, the relative error in the density comes out to be 0.0953 and the percentage error will be simply by multiplying it by 100. So it comes out to be 9.53%. Let us attempt last numerical. If two resistances are given and they are arranged in series and then in parallel, we have to find the error in the equivalent resistance. When they are arranged in series, that is, we simply have to arrange the two resistances in such a manner that their values get added up. So whatever values are given in the numerical, they are simply added up. So the magnitudes are R1 plus R2, so they are added, that is 2 plus 12.3, and their errors are also given as 0.1 and 0.2, they are also added. So the resultant comes out to be 14.3 plus minus 0.3 ohm. And when they are arranged in parallel, we have to first find their parallel combination. So the parallel combination is obtained by the parallel combination formula, that is 1 upon R1 plus 1 upon R2. The resultant or the parallel combination resistance is R1 into R2 upon sum of the two resistances. The sum we have just calculated in the above here, that is, it comes out to be 14.3. Now the parallel combination resistance is obtained by putting down all the values as 1.72 ohm, and the relative error in parallel combination is this. It has been obtained from this formula only, that is relative error in R1 plus relative error in R2 plus relative error of the denominator, that is the series combination. Again put down all the values, we have obtained as 0.14. So the parallel combination resistance within the error limits becomes 1.72 plus minus 0.14 ohm. Thanks for watching. Please like, share and subscribe.